So, you're an aspiring machine learning engineer. You've done the courses, you've learned the algorithms, but you just can't seem to get noticed. Well, this explainer is for you. It is a super frustrating place to be, right? You've put in all the hours, you get the concepts, but your portfolio, it just isn't making an impact. If that sounds familiar, trust me, you are not alone. Today, we're going to pinpoint exactly why that is and, more importantly, what you can do about it. You know, this quote from Marina Weiss just hits the nail on the head. There is this huge, huge gap between the academic projects we all start with and the kind of work that proves you're actually ready for a real-world engineering job. And this, right here, is the crucial mindset shift you need to make. See, a model is basically an experiment stuck in a notebook. A system, on the other hand, is a complete end-to-end solution that solves a real problem. And building systems? That's what gets you hired. All right, so let's dive in. We're going to walk through this whole roadmap together. We'll start with something I call the tutorial trap and end with exactly how to showcase your work so you finally land that job. First up, let's talk about the tutorial trap. We're going to break down why those starter projects, while they're great for learning, just fall flat in a professional portfolio. The contrast here is everything. Look, people in the industry know that something like 80% of machine learning work is just wrestling with messy data. It's not the glamorous model building part. A real production system isn't about getting 99% accuracy on some perfect, clean file. It's about delivering actual value, reliably, dealing with messy inputs, and making it accessible to users through something like an API. That is the difference recruiters are looking for. So, how do you actually bridge that gap? Well, it's not a single leap. It's more like a ladder, a clear progression we can break down into 5 distinct levels. Let's walk through them right now. Level 1 is where we all start out, the notebook experiment. This is your classic Kaggle project, right? You're working with a nice, clean, prepackaged dataset all inside one single notebook. And look, this stage is absolutely essential for learning the fundamentals. You load up a clean dataset, you explore it, you train a simple model. But here's the catch, the big limitation. It proves nothing about your ability to handle the chaos and complexity of a real-world application. Now, at level 2, you start thinking like an engineer. You're moving beyond that single, messy notebook into a properly structured Python project with separate files and modules. You start using Git for version control, and you tackle messier, more realistic data, the kind you'll actually see on the job. Okay, level 3. This is the game changer. This is where you make the real leap into machine learning engineering. You're not just building a model anymore. You're building a service. You package it with Docker, you expose it with an API so people can use it, and you start thinking about monitoring. Honestly, for most entry-level ML engineering roles, this is the bare minimum. Level 4 is where we get into the big leagues. We're talking industrial scale. This is for more senior and MLOps-focused roles. Here, you're building a super robust, scalable system on a cloud platform like AWS or Google Cloud, and you're using advanced tools to manage all that complexity. And finally, level 5. This is the research frontier. This is for those roles where your job isn't just to apply the existing methods, but to invent totally new ones. You're pushing the boundaries of the field, and that often leads to getting published at major AI conferences. So why is that jump from a learning project to a deployed system so massive? Well, it's because the entire world changes when you go from the clean room of academia to the messy reality of production. Let's look at 3 of the biggest gaps. This really gets to the heart of the challenge. In the real world, the best model is almost never the one with the highest accuracy. It's the one that balances all these competing needs. It has to be fast enough for users, cheap enough to run, and simple enough for the team to actually understand and fix when it breaks. And things like fairness and bias, a model that's unfair can seriously damage a business. It's this complex balancing act that those single metric tutorial projects completely ignore. Okay, so we get it. We need to build a level 3 system. But what does that actually look like? How do you do it? Let's walk through a really practical MLOps blueprint. But first, let's just get on the same page. What even is MLOps? Think of it as the engineering discipline that turns a cool model on your laptop into a reliable, automated, and scalable product that can handle millions of users. And here it is. This is your playbook. You start with messy, real-world data. You train a model. You wrap that model in an API. You package the whole thing up with Docker, you deploy it, and then, crucially, you monitor it.
Following this life cycle sends the clearest possible signal to an employer that you can ship things, not just experiment.
Now for what is probably the number one question I get. Okay, that's great, but what should I build? And the simple answer is the best projects are the ones that solve a problem you genuinely care about, even if it's a small or kind of quirky one.
And these examples are just brilliant, right? A project doesn't have to change the world to be impressive. Days to Banana Death is memorable, it's fun, and it's technically solid. It proves you can identify a problem, go out and collect your own data, and build a full solution from scratch. That kind of creativity is what makes you stand out in a sea of identical tutorial projects.
Okay, and finally, building an amazing system isn't enough if you can't talk about it. How you describe your work on your resume, on LinkedIn, and in interviews is just as important as the code you wrote.
This might be the single most important slide here. You have to stop talking about the algorithm you used, start talking about this system you built and the problem you solved. Recruiters aren't hiring algorithm experts, they're hiring engineers who build solutions. Frame your work this way and you are already way ahead of the pack.
So I'll leave you with this one question. The next time you sit down to start something new, ask yourself, are you just building another project or are you building your first system? Because that choice right there will define your journey, and ultimately, it's what's going to land you the job.